Today's lesson is on how to graph quadratic functions. Quadratic functions is a function to the second degree, so it will have a variable being squared. There are three main forms of a quadratic function that we will work with. The first one is standard form. In standard form, the variables go from the highest exponent to the lowest exponent. So the x squared comes first, then the x, then just a constant with no variables. In vertex form, we have a parentheses with an expression with the x being squared, and there could be a number outside the parentheses, and there could be a number outside the parentheses being added or subtracted on. And factored form is going to be a number outside the parentheses being multiplied by two sets of parentheses with the r's. The r's stand for the roots, and we will learn more about that in the next lesson. So take a second to copy down all three forms of a quadratic function. When we have learned before, we have seen standard form and we have seen factored form. We know how to turn standard form into factored form. In order to turn standard form into factored form, we have to factor the standard form. So that is why it's called factored form. We will learn more about vertex form in the next few lessons. Now the shifts in a quadratic function for the graph are the same as the shifts in an absolute value. The only difference is what the graph looks like. The graph of a quadratic function will look like a U shape. So as an absolute value is a V shape, the graph of a quadratic function will be a U shape. And this graph is called a parabola. So that is the name of a quadratic graph. A quadratic function is a U shape and it is called a parabola. The first question. Given the graph of the quadratic function in the form f of x equals ax squared plus bx plus c, what will happen to the graph if a is multiplied by a negative 4? Take a second to copy down the question. When I look at the form that I'm given, ax squared plus bx plus c, that is written in standard form. Now, in this case, the a is multiplied by a negative 4. The same way the a used to be multiplied in the absolute value functions, it's the same thing. So since it's multiplied by a negative, our graph would be flipped upside down. And since it is a 4, that number is greater than 1, so that means our graph would be more narrow. Remember, it's the opposite. The bigger the number is, the more narrow your graph is going to become. And the second question. The vertex of the parabola represented by f of x equals x squared minus 4x plus 3 has coordinates 2, negative 1. Find the coordinates of the vertex of the parabola defined by g of x equals f of x minus 2. Explain how you arrived at your answer. Take a second to copy down the problem. we're talking about a quadratic function, the vertex of a quadratic function is also called the turning point. So in this graph, this point is your vertex. It's called your vertex because here my graph is going down. Then, once my graph hits this vertex or turning point, it turns and starts to go up. So that is what is represented by the vertex of a quadratic function. So for this function, f of x equals x squared minus 4x plus 3, the vertex is 2, negative 1. So I'm going to draw another graph just to show what that looks like. So my vertex is at 2, negative 1. So that would be somewhere down here. That's all that I know about the graphs. That's all I'm going to be concerned about. Now I'm going to look and see that I have f of x minus 2. Since this minus 2 is with the x, that means I'm moving along my x-axis. And the same way with the absolute value, when it's with the x, it's the opposite. So since it's a minus 2, that means I'm moving to the right 2. So I take my vertex and it just moves to the right 2 spaces, 1, 2. And this would be my new vertex, which is 1, 2, 3, 4, negative 1. So my new vertex is 4, negative 1. And this explanation here of moving right 2, that's how I arrived at my answer. So the new vertex of g of x is 4, negative 1.